Ram Ram guys, today we see about LeetCode question number 257, which says that given the root of a binary tree, return all root to leaf paths. A leaf is a node with no children. So as you know, leaf node is a node with no children, and we need to return all root to leaf path, which is, let's see with an example, which is 1 2 5. This is one path, 1 3. This is one path from root to leaf. This is one path from root to leaf. So we need to return this. So this is simple way question is this. So how we approach that question? So first of all, which traversal we use to do this question? So as you know, BFS travels level wise. So if we travel level wise, we do not reach easily to root to the leaf nodes from root node. So it's not preferable. So let's see how we solve this question using DFS, which is only pre-order. Because in order and post order, we basically processes the node after left traversal, and in post order we processes the node after left and right traversal of a tree. But in this case, as we need to do maintain a path and return and string, such that if I visited one, 1 is included, 2 visited, 2 is included, 5 visited, 5 is included. So we need to include that part, include that node's value in as we go far away. So that's why we use pre-order, basically DFS pre-order to solve this question. To solve this question, you more understand when I dry run this example. So let's dry run this example, how we do that. So first of all, what we do is that we move, this is the root node. So we maintain a string. First of all, we pass an empty string from main function. So let's pass this. Also make an empty array in which we add strings when we are at leaf node. Let's see it with example. Suppose this is a root node, then we traverse it, we pass this node to next node, we pass this string to next node. What we do is that if string is empty, we only append root dot value in it, because if there is some edge case which requires that if we have only one node, then we do not return one and this arrow, we need to return only one. So that's why if string is empty, what we do is that we only add this root dot value into that string and pass to another function, pass to other recursive call, which is left subtree, we pass to left subtree. Now here we go. Now what we do, we are here now. Now similarly as recursion do, we traverse to left by passing. Now it is not case that string is empty, so what we do is that we add arrow plus root dot value into the string and pass to left. Now I pass to left, but I see that left is null. What we do, we return, because we need not path from, we don't need this path 1 2, we need the path to leaf node, root to leaf node. That's why I return null. So what I do now, I pass this to its right child because left subtree is done for two node 2. Now I pass it to left right child. Now what we have to do is that now we observe that this is a leaf node. So now what we do, we append string the arrow and 5 and root dot value which is 5 here. And if it is a leaf node like in this case, because it's left and right both are null, we append it to our answer list. We append it to our answer list. Okay, so that's how we works. Now it come recursive call. As recursion works, recursion goes here. Now recursion moves here, then here, then now recursion is here. Left subtree for 1 is done. Now what we do is that we traverse here. As I said you, we pass 1 to our left, which we already do. Now pass to right. Now as I pass, I observe that this is also a leaf node. What I do, I append the arrow and root dot value. Root means this dot value because this is a root for recursive call which we apply. You more understand when I uh, or when I provide you and explain you code part. Then we append this to our answer because this is a leaf node. So that's how our this question works. So now let's see its code part. So it is a code which I write in Java. You can also write this logic in C++. For now I write it in Java. What I do is that I made a first I made a answer list, then I made a helper function so that I can traverse using DFS, then root answer which is this list for storing answer, final answer our, and the empty string I pass. Then if root is null, as I taught you, if root is null, we simply return. If string is empty, if string is not empty, then we add arrow. Otherwise, what we do, we we do s empty string dot value. So that's how we do string adding value and arrow. Then if our node is a leaf node, then what we do, we add that into our final answer and return. Now we similarly we do this process for left node. We traverse basically the tree using these two calls, recursive calls. So we travel left, right, and explore all paths. So that's how we solve this question. The time complexity of this question is big of n because we travel whole tree, not subtree. We traverse whole tree, and the space complexity for this is big of h because at max TFS goes big of h, which is height of tree. So that's why the as you see in recursion maximum calls can be n because in case of skewed tree this can go this way. So maximum calls can be n in case of skewed tree. So recursive stack can be n, but it is generally big of h. Okay. So that's all about this question. Thank you so much for watching. Bye.